So this is Containing Chaos with Kubernetes. My name is Terrence Ryan, and I'm a developer advocate for Google. I work for the Google Cloud Platform team, but Kubernetes is kind of outside of that. Before I go further, though, I'd like to know who you guys are. It helps me know what metaphors I can make and what groups I can make fun of, that sort of thing. So I assume you guys are all developers. Is anybody here not a developer? Okay, good. Anybody here do systems on the side as well as developing? So is it because you like DevOps, or is it because your company hates you and won't hire more people? Latter. Okay. Okay. And how many people have played around with Docker? Containers? Good. So good. I don't have to explain containers. Great. Okay. So let's get right into it, and let's talk about what problem we're trying to solve with Kubernetes. So you guys may have come over to containers already, right? Here's a typical app, right? I have a front end and services built together, so it's my web serving and PHP layer in the same container. I have a back end that I've written up in MySQL, and my architecture looks a little bit like this. And when I need more resources, I need more power behind my cluster, well, I can just spin up more containers and have the front end work a little harder. But someone might point out to me that, like, from a container perspective, this is bad for a number of reasons, but chiefly because this is not good container hygiene, right? I'm doing too much in one container. I should really split these up, right? So let's turn this just into services. So it's just serving PHP API calls. And then the front end, I simplify and make it just Nginx. So I have just a simple HTTP web server serving up HTML, JavaScript, and CSS. So now my environment looks a little bit like this. Still kind of working, still okay. But then someone will point out, like, hey, the whole thing with containers is that they can just go away at any time. So they can go away at any time, and database is not, we don't want that, right? Like, a database just going away at any time is bad, right? So easy fix, we add an external volume to it. So that if the container goes down, the data is stored elsewhere. So now our environment looks a little bit like this. And if I need to scale it out more, I can add even more scale if I want. But all of this is an abstraction. All of this is sort of a lie, right? Because under the covers, even though I have all these systems and all these containers running, there's still a machine that I have to contend with that has resources and could go down. So I've got a single point of failure, right? So I need to change this over and split it up and run my containers in multiple machines and wire all that up. And it'd be nice if I can pull the volume out of that too, so that has some redundancy. So now if one of my machines were to go down, I have to move all my pods over. And that's like a lot to manage, right? Like, I've added a whole lot of complexity to this problem, but I haven't really gotten a lot of bang for the buck, right? It's more complex, great. And well, that's like good for job security, I guess. It's not really good for like sleeping at night and not being paged. So Kubernetes solves this problem for you, and it solves it in kind of a different way, right? Instead of spinning up all those individual machines, you basically just tell Kubernetes, I want 4 of these, 3 of these, 1 of these. Kubernetes manages the hardware for you, manages the servers that are going to be running the containers for you, and you don't have to worry about it. So we call Kubernetes a container orchestration system. It is open source. It was started by us. It was started by Google. But now it is contributed to by others. And in fact, the largest group, if you like, here are all the Google contributions, here are all the Red Hat contributions, here are all the CoreOS contributions. The largest single group like that is actually individual contributors that are not part of a bigger organization, which is kind of great. Like we have like a really robust community, and I'll talk a little bit more about that in a minute. So to understand Kubernetes, there's some concepts we have to kind of go through. And the first is that our containers have to be ephemeral. And the idea is that they're not, they're stateless and they can go away, and it's fine, right? So you need to not store state in any of the containers that you're working with. So, and we're all used to this, right? We have our cluster and we have our individual named machines, and we have a mail cluster, and we're clever and we named them Mercuries and Hermes because they're messengers. And like these are zodiac signs because maybe someday we'll have 12 of them. We all remember this. And if one of these machines goes down, right, Todd, I guess not Todd here, like Marco has to go down to the server room and actually physically pull stuff out, right? So what we like in the Kubernetes, in the container world, is what we call cattle, not pets. Have people heard this metaphor before? Cattle, not pets? Okay. So cattle, or pets, it has a name. It's unique or rare. It gets personal attention, and if it goes down, it gets sick in the middle of the night, you're up all night trying to make it better. On the other hand, cattle, each one has a number, right? We don't care about the individual identities of them. One is much like any other one. You run them as a group, and if one gets sick, you make hamburgers, right? Right, here's where I'm not like an expert in animal husbandry, but I know that making hamburgers from sick cow is a bad idea. So make a leather jacket, right? But so that's how we want to treat our servers, like cattle. Like we don't care about an individual machine or individual process running because we can just spin up another one. The next concept is desired state. Now, you may be familiar with like the converse of, or the opposite of desired state, which is imperative or just a build script, right? So I say create Docker images, and then after I create the Docker images, I launch the backend, the database, because the database has to run before the API can run. Otherwise, we'll get errors. So we run the backend, and then we launch the service layer, and then after we launch the service layer, we launch the front ends, right? Because each one is dependent on the one before it. And if one of these machines were to blow up, someone is going to have to take a step in and do something about it. So the converse of this is what we call desired state, where you just say, hey, there should be 3 front ends, 2 services layers, and 1 back end, and Kubernetes just makes it happen. And you'll notice that certain things spun up before other things, and that's fine. You have to change some of your architecture on your application side to be able to long poll to make sure the database is up and retry instead of just failing. But now I have the system that I just tell it this is how much I want to run. And if one of them were to go down without me doing anything, it'll just bring it back up. So that's a desired state. And so in the cattle, not pets, we want employees, not children, right? So an employee, you have a long day at work, you tell them, hey, go home, get some sleep, rest. They may or may not do that, but the idea here is that they know what they have to do to go home, recharge, and come back the next day to do work. Those of you who have children know it doesn't work that way, right? Children, it's go upstairs, get undressed, put on pajamas, brush your teeth, pick out 2 stories. And those of you that don't have children might say, do you really have to go through all those steps? Like, do you really have to tell them to go upstairs? Yes, you do. Because if you don't, if you read the steps, you'll end up, you don't tell them to go upstairs, you'll end up with a naked child in your living room. And much like servers, when one of those steps goes wrong, you'll see things that you don't want to see. So we want our services to act like employees and not children. So components. All right, this is a lot of definitions of things that you need to know to kind of keep Kubernetes running. So when I talk about nodes are the machines that run Kubernetes. They're the individual clusters. Containers are going to run on these. They can be hardware or virtual, but they are not part of the Kubernetes system. They are what Kubernetes is running on top of. Then we have containers. Now, containers are what we call subatomic parts of Kubernetes. They're Dockerfiles just like we're used to. And in fact, I develop on Docker and run in production on Kubernetes with the same files. So you don't have to choose one or the other. You can use both. Then we go to pods. Now, pods are the atomic component of Kubernetes. When you spin up something, you're spinning up a pod and not a container. They are made from 1 or more containers. And if you have more than 1 container in your pod, they're going to share IP address, local storage, and namespace. It's okay to have just one pod per container. A lot of times when you read the documentation, it'll say one or more, one or more, one or more, one or more, but it's okay to just have one, right? And most of the time I do stuff, I'm only running one container in a pod. Now you might ask, why would you want to do more than one container in a pod? Why do we have this separate thing that's outside of just containers? There are a couple reasons. One, we talked about container hygiene, that they should only do one thing. So let's say you've got a web server, and so you're serving up web pages, and you're refreshing them from a source every night. Like, this isn't the best architecture, but like it's for example. So good container hygiene would say these should be two separate processes, a sink and a HTTP serve. But the HTTP server needs the files that get synced. So you put them both in the same container. You put them both in the same pod, and they share local storage. So the one process will write to local storage, and the other process will serve up the web pages. Also good for converting a LAMP box to containers, if you are so inclined to do that. Not that anyone ever takes a LAMP box and accidentally moves to production with it, but if like your friends did that, you could recommend this to move them over. This is a quick kind of configuration, like what it's going to be YAML. I apologize if anybody hates YAML. But this is what this looks like, and the key thing here is this image. So this is where we spec what the container that we're using. And this image you'll see is, this is just when you write a Docker command line and you say from image, this is the same thing. So you can use anything from the Docker repo. There's also, you can host your own Docker repo and build your own images and pull them into Kubernetes, which is what you tend to do. Okay, so you don't actually spin up pods because pods don't have any concept of desired state. If a pod goes down and it's just a pod, it will stay down. So you have these things called controllers, specifically replication controllers. Replication controllers observe how many pods are running, makes a diff on the config, what should be running, and then acts. Usually it's going to spin up another one because one went down, but it could, if you had a reschedule and you somehow have more than 3 pods and you only wanted 3, it'll spin down pods. So this is what Replication Controller looks like. You'll notice on the right, I have pretty much the same thing as my pod spec, which is by design. You don't actually do a naked pod, you do a pod within a controller. And here's where I set replicas to, and that makes it a replication controller. Now, we've moved away from replication controllers to this thing called Replica Set, which is exactly the same thing, hence the Simpsons GIF. But it's slightly different in the way you select them. The reason I bring this up is because a lot of the documentation will say replication controller. Like old documentation, old blog posts will point to replication controllers, but you can use replica sets and they're exactly the same thing and they're fine. You don't actually spin up a replica set. You use this thing called a deployment. So deployment is an overarching piece of control over top of a replica set. It helps with rolling updates and other things. What's great about them, if you look, the spec is a lot smaller. So here's where I define my pod, and then I just say we're going to rolling update these in replicas too. And that's a lot less configuration code, so that's why I like that. So up until now, we've been talking about spinning up pods. And pods are ephemeral, but at some point you need to expose it, right? You need someone to go to a website that's served up by your pods. How do you do that? There's this concept called services. Services are endpoints which define access to your applications. They get a virtual IP address, and they can also get a public load balancer. So you can either keep them private, so you can only pull from other Kubernetes hosts, or you can make it public to the world. It's used for exposing application to other clients and non-Kubernetes clients. This is what the code for this looks like. Nothing too crazy here. I will pull this out. Here's the port number. The fact that I say load balancer here makes it public. If I don't have that line, it stays a private service. So all this is a concept called labels. So They're metadata that you can add to any of these. They've been sprinkled throughout the examples I've shown you. And they basically just allow you to create, label these things. They're completely arbitrary, so you can make whatever key value pair you want. I use app, tier, and environment, but you could use anything you want. But it allows me to select individual groups. I want all of the front ends. I want all of the prod. And they work with services. So here in this deployment, I have a label of app to do FE. So app equals to do front end. And that spins up these pods. In my service, I say selector app to do FE. Those two equal, so it knows it's going to wrap a service and serve up port 80 on these pods to that IP address. And since it's type load balancer.
Okay, and this is for the recording, so I'll make sure I talk into it. All right, so last bit of kind of configuration information is networking. All pod IP addresses are routable, which is in contrast to Docker, where like you have to create connections between all of your, like if you want to connect between two Docker hosts, you have to specifically call out that connection. Whereas with Kubernetes, as long as they have an IP address, they can talk to one another, and that that connection goes across cluster nodes. So it does not matter if they're on different machines. We handle all of the networking for the entire setup. So I'm going to sum up all this real quick, because we went through pretty quickly. So Kubernetes uses containers, but you never actually use containers because you use these things called pods, but you never actually spin up a pod by itself. You spin them up with this thing called a Replication Controller, but we don't actually use Replication Controllers anymore. We use this thing called a Replica Set. And you don't actually do a Replica Set. You use a deployment to do that. You wrap all this up and show it through a service. Simple, right? Easy? Right? Straightforward? All right. Why? The reason why is because Kubernetes is actually pretty active as a project. There's a very active community, and we're changing things in response to what we need in the environment. So for a month, and this is over the Christmas holidays, there were 791 pull requests, of which we merged 541 of them. That is an incredibly active GitHub project. We get like average about 40 pull requests a day on Kubernetes. So it's constantly merging and it's constantly growing, and that's why some of this stuff is a little bit like, that's why like things like Replication Set happens instead of Replication Controller. But it's complex stuff. We're not, we're trying to tackle a complex problem here, and so there's some complexity. So I'm going to show you a quick demo of Kubernetes in action. So before the demo, I have spun up a Kubernetes cluster. I have built disks, I have built Docker images, and I pushed them to a Docker repository. All of this, if I did it from scratch in front of you, would take about 10 minutes, and I only have 10 minutes left. So I'm going to skip doing it by hand. I did it, we'll get to the interesting part, which is deploying on top of Kubernetes. I have a very simple app here, a 2-layer app. It is, I know this is shocking, a to-do app written in Bootstrap. I know it's shocking and amazing. No one's ever done a to-do app in Bootstrap, but it does show off this pretty nicely. So I am going to spin up a Kubernetes cluster here. An app in Kubernetes. So this is a visualizer that's going to help us see the parts of the setup startup, and I am going to run. Now, keep in mind I'm running over the wireless Wi-Fi here, so we will see. But I'm going to do all this with a deploy file. A make file. And we'll see all the commands come up. Those are all the individual commands. We see that we've updated. I haven't updated. That's fine. I didn't want to do it right before the talk anyway. And so now we are applying individual YAML files to our Kubernetes cluster. And we should start seeing them start up here. They are not showing up. There we go. So they're starting up there. And we have a environment. So we have a MySQL server that's still spinning up. That's why it's yellow. Spins up a little slower than the PHP servers. We have a service. This is actually a light green. That's for private. Then I have 2 front ends that are running a front end service that's on a public IP address. But it takes a little while for it to get that from the environment. So while we're waiting for that, we're going to have some fun. should see, you see immediately one died and went red and died, and then the yellow one spun up. Why? Desired state, right? Like, even if one goes down, we wanted to keep running this. Now, that IP is open, so I'm going to go to it, and there we see our app is all ready. I gave this in Milan yesterday. You see me greeting Milana. And this is the thing, that all of this has gone away, right? And the environment comes back up, and because I have the disks already built, it works. So where am I? I am in Verona. Verona. My messages are getting shorter. There we go. Let me see. All right. So that is a quick demo of Kubernetes running. One of the things, though, that is important to keep in mind about Kubernetes is that to spin up all of this for one app is sort of wasteful. What I really want to do is, now that I have my cluster running, I want to spin up many, many apps. So this is where Kubernetes actually comes into play. I've got this whole environment that I can just run app after app after app. And I just deployed, pushed to deploy on a whole bunch of different apps. Drupal 7, Drupal 8, WordPress, a Node.js app, all with their own database, all with their own public IP address and private service for their databases. So now I've created a whole environment for everything I need right here, right? So this is where Kubernetes, I put all these resources in one basket, and then I just dump as many applications into this as I can as will fit. And as you can see, this relatively low power cluster was able to handle all of this. Now, I am gonna move forward. There's a whole bunch of stuff that I haven't shown you, but I kind of want to get through a little bit more than I had to say. There's logging, there's monitoring, there's events, there's a web interface, config maps, jobs, secrets, horizontal auto-scaling, Kubernetes, where you can take Kubernetes clusters in multiple data centers and connect them. They become one logical server, which is really cool. It means you can host on-prem Kubernetes and also host on the cloud and connect the two. And so you can use the cloud as over for your usage, and it runs AWS or Google Cloud Platform or wherever you want to run. Quick comparisons. People ask, how do we compare against Docker? This is sort of how I see this. Docker Compose, Docker Machine, and Docker with Docker Swarm built into it kind of handle a lot of the same things Kubernetes handles. Docker Machine does a little bit more on being able to be agnostic as to your environment. But we add a whole bunch of things on top of that: scheduled jobs, stateful set, auto-scaling, config maps. So Docker's logos are much cooler than I acknowledge that. Because they're really awesome. I really love these. I wish they were ours. So container engine. So I've mostly talked about developing on Kubernetes, not really developing, not running Kubernetes. So if you want to set up a cluster, it goes something like this. Choose an infrastructure. You can choose anything. Like I said before, we run on a whole bunch of things. I, of course, have my preferences, but all of these will run. Choose a node OS. So then you provision your machines, you boot the VMs, you install and run all the kube components on them, you configure networking, so IP address ranges for pods, services, service discovery network. You then start clustering services, DNS, logging, monitoring, all these things you run it. Then you manage nodes, the kernel upgrades, and OS updates, hardware failures. So basically, you can manage all of this, or there's this container engine you can pull out platform with a button, right? You press that, all of that it'll handle it. It'll build a cluster for you, and it is a really great way of dipping your toes in. So it's hosted Kubernetes. A few smart defaults are set. Sorry, a few smart defaults are set, and allows you for dipping your feet in, and also allows for node auto scaling. So I'll skip through this. Conclusions. So Kubernetes is open source, and we want help. Kubernetes IO resource for getting to Kubernetes, and at the end I'll have a link to the slides, so you don't have to take pictures if you don't if I'm going too quick. You can just download the slides. Kubernetes is open source. Roadmap. We are on 1.6 right now. It was released in March. So what we added, this last one, is you can now do up to 5,000 nodes and 150,000 pods per cluster. It's kind of nice. Advanced scheduling, some storage enhancements for working with other platforms, including ours, but including AWS, Azure, OpenStack, VMware. One of the cool alphas that we added to this was GPU support. So running GPU processes on Kubernetes clusters right from the pods. Good stuff. 1.7, I really don't know what's happened with 1.7 just because I've stopped guessing what we're going to do. June 2017 is when it's coming out, so like a month. They're pretty good at, we release every 3 months, so expect it in June. If you like Kubernetes, wondering what the hell am I getting into here, Container Engine, we have a $300 free trial. So run it on us, learn it on us, then run it wherever you need to run it. We're cool with that. Actually, I'm cool with that. Maybe like my sales guys might not be, but they're not here. There's also MiniCube, which is running a local version of a Kubernetes cluster. It's another way of dipping your toes in. We've been doing this on containers for 10 years. We've run everything at Google in containers, including our VMs. When you have a Google Cloud Platform VM, it's actually running inside a Google-based container, not running Kubernetes, running our own stuff. But we really believe containers are the way to get scale out of our hardware. We launch 2 billion containers a week, so we really believe in this. We think containers are the way to manage scale. They can also manage deployment, make a whole other things easy, but we do it for scale. You should carefully consider whether running everything on containers is right for you. And the reason why I say this is because I don't want you to take away, hey, the Google guy, he said you should run everything on containers. No, I didn't say that. I said you should really think very hard before you run everything on containers. Because it might be right for your environment, it might not be. So I love them. I think they're great. I solve a lot of problems with them. But make sure they actually solve your problems before you switch to them. With that, I'll say thank you. You can download the deck there. My Twitter handle is here. If you have questions, you can, or want to heckle me, go for that. And as always, I should remind you, the joined in talk short code is there. With that, I'll say thank you guys very much. And I think I don't have really time for questions, but I will hang around and I will make myself available. All right, thank you very much.